This is Mr. Martin. This video is going to cover some limits from the left and the right with piecewise functions. And this is going to lead us into a definition of continuity also. So I'll be mentioning some stuff that we'll be talking about pretty soon with regards to continuity, and it's just kind of a preview of things to come, so keep that in mind. So if you haven't yet, you can download and print out this worksheet that we're working on. It's on the Flipped Videos website. You'll see it there underneath the video for section 11.4. All right, so for the function g that's graphed here, we want to find the limit as x approaches 0 from the left, as x approaches 0 from the right. As x approaches 0, remember this means from the left and the right at the same time. And then we also want to find the value of the function at 0. So let's start with part A, the limit as x approaches 0 from the left. So if I'm at 0, if I'm approaching 0 and I want to approach it from the left, then I start somewhere on the curve and I start following it towards the value that I'm looking for. So I'm following it towards 0. So as I approach it from the left, the y value that I'm approaching is 1. So this is going to equal 1. Now, as I approach it from the right, so now I find myself on the curve on the right side of 0, and I'm going to approach it from this side, and I can see the y value I'm approaching is still going to be 1. Now, when it says as x approaches 0, this means it's approaching from the left and the right at the same time. Now, if you notice, these two answers are the same. So the only way we can have a limit as x approaches 0 is if the limit from the left and the limit from the right are the same, which means that the limit from both sides at the same time will be the same. So that's also going to be 1. If there was a different limit from the left and the right, then this would be does not exist. We would just write DNE. All right, and then for part D here, the value of the function at 0. So at 0, we can see there's a hole up here at 1, but there's a solid dot here, a point here at 0. So the value of the function at 0 is going to be 0, even though the limit as we approach it is something different. All right, let's move on to number 2. So we have the limit as x approaches 3 from the left side. So again, I'm going to start at the left of 3 and follow this down. And we can see we're not going to approach a whole number value. Or a real number value, a real number value. We're going towards negative infinity. So depending on the course that you're taking or the book that you're using, we can have two possible answers, and I'll accept either one. So our book, since this does not approach a real number answer, we would say DNE, but if you want to put negative infinity, I'll accept that as well, because some courses and some books will do that. All right, and now, as we approach 3 from the positive side, so now we're on the right side of 3, and we're following the graph towards 3. Again, we're going to be approaching negative infinity, so we can either say DNE does not exist or negative infinity. All right, now, since these are technically the same, they're both either DNE or they're both either negative infinity. As we approach 3 from both sides at the same time, again, you can write does not exist, or you can say it approaches negative infinity. Now, the value of the function at 3, that's going to be this point right here. So the value of the function at 3 is going to be 1, even though the limits as we approach 3 are not the same. All right, moving on to number 3. So we have the limit as x approaches 3 from the left. So now I'm the left side of 3 going towards 3. And my y value as I go to the right here is going to be 0. And now the limit as x approaches 3 from the positive side. So we're starting on the positive side of 3 going towards 3. So now my limit, we're getting closer to a y value of 3. Actually, it's a constant value, but that's 3. So now if you notice, these are different values now. So the limit as we approach 3 from both sides at the same time does not exist because the limits from the left and the right are different. And now the value of the function at 3. So at 3 we have this point here which is at 1. Alright, number 4, we've got some corrections to make here. This should be a 2, and this should be a 2, and this should be a 2. Alright, so the limit as we approach -1 from the negative side. So here's -1. If I approach it from the negative side, the y value that it looks like I'm approaching, we're going to estimate it here. We're going to estimate it to be 0.25. And as we approach -1 from the right side, so now we're approaching -1 this way. So we don't have to have a discontinuity or a hole or anything there. It could just be some point that we're approaching on a smooth part of the curve. So as we approach from the right side, that's also going to be 0.25. So now since these are the same from the left and from the right, the limit as we approach -1 from both sides at the same time will be the same value, 0.25. Now, let's take a look as we approach 2 from the negative side. So let's get rid of this stuff. As we approach 2 from the negative side, we're approaching 2. As we approach 2 from the right side, so as my x values are getting closer to 2, my y values are getting closer to 0. And we can see since these are different values, the limit as x approaches 2 from both sides at the same time does not exist. Alright, moving on. Why don't you go ahead and give this a try, and then when you restart the video, the solution will be there, and you can check, and as always, you can let me know if you have questions. So pause the video now, and when you restart, the answers will be there. Alright, so hopefully your answers look something like this. For part A, we either have infinity or does not exist because we're going up forever. And then as we approach from the right side, we have 1. And since the values from the left and the right are approaching different values, then the value as we approach 1 from both sides at the same time does not exist. And the value of the function at 1, that's this point here, is going to be 2. Alright, so for these last two, we have 3 constraints, or last few. We have a bunch of constraints that we have to satisfy. So we're going to sketch a possible graph for a function f with a specified property. So we know the domain is going to go from -1 to 1. So I'm just going to spread this out a little. So I'm going to make this -1, and I'm going to make this +1. And we have the value of the function at -1 is the same as the value of the function at 0, which is the same as the value at 1. So we have these 3 points that are defined as 0. So -1, we'll just put these in red. I have 0. F of 0 is also 0. And f of 1 is also 0. So we have those 3 points. And then the limit as x approaches -1 from the positive side. Okay, so we wouldn't have it from the negative side because our domain stops at -1. is the same as the limit as x approaches 0, so that would be from both sides, which is the same as the limit as x approaches 1 from the negative side, and those are all going to equal 1. So let's make this 1 over here. So since I already have values defined there, I'm going to put some open circles. So I have an open circle here, and I'm going to have an open circle here, and I'm going to have an open circle here. So somehow we just need to connect these. It really doesn't matter how I connect it. So I'm going to do something like this. Again, you can just draw a straight line in between them. So the limit as x approaches -1 from the positive side. So that's going this way. It's going to equal 1. And as we approach 0, so as we approach 0 from both sides, that's going to equal 1 also. And as we approach 1 from the left, that's going this way. That's also going to equal 1. All right, so these are great problems that really test your understanding of limits. So as always, make sure you ask questions. All right, number 7. Again, we have 3 different constraints. The domain goes from -infinity to 1. And the value of the function at -2 is the same as the value at 1. So that's going to be 1. So let's just go every 3 here. So that's -1, -2, +1, +2. Here's 1. So the value at these 2 places is 1. So at -2, it's 1. And at 1, it's also 1. So these are defined values. And the limit as x approaches -2 is going to be +infinity. So we're going to look something like this. We're going to go up that way. And we're also going to go up that way. Let's figure out what we need to do here. And actually, let's fix this a little bit. We can actually just go right like that. All right, let's double check to make sure that we've fulfilled all the constraints. So we have these 2 values. At -2 it's 1, and at 1 it's 1. The domain goes from -infinity, so we'll put an arrow there, and it stops at 1, which it does. And as we approach -2 from both sides, we're going to +infinity. So there we have it. All right, and the last one, we're going to go from -2 to 1. So I've got -1, -2, here's +1, and +2, and here's 1. All right, so I've got 3 values that equal 0. So at -2, I have 0. At 0, I have 0. And at 1, I also have 0. And then I have some limits. As x approaches -2 from the positive side, that's going to equal 2. So let's put one more point up here at 2. So I'm just going to put an open circle right here for now. And then as we approach 0, it's going to be 0. So I already have a point there, so that's okay. We'll leave that there. And as x approaches 1 from the negative side, that's 1. So let's put a circle here. So basically what we need to do is just somehow connect these 3 spots here. So again, it really doesn't matter what you do. All right, so something like this. Again, it really doesn't matter. This one here means from the left and the right again. So from the left and the right, as we approach 0, our y value is approaching 0. And then as we approach -2 from the right, we're approaching 2. And as we approach 1 from the left, it's approaching 1. So that works out also. All right, so that's the end of this video. If you have any questions, make sure you ask, and we'll see you next time.